In this video, we're going to talk about complex numbers. Up to this point, we haven't been able to work with a negative number under a radical. So what we're going to do is we are going to define the square root of -1 as I. And what the I stands for is that this is an imaginary number. So if we say that the square root of -1 is I, that means I times I is equal to -1, or we could also write this as I squared is equal to -1. So once we know this, we can also work with higher powers of I that we'll talk about later. But from now on, we will no longer say that a negative under a radical is not a real number. We will refer to it as an imaginary number, and we will be using I. So let's start by taking the square root of -16. So up until this point, again, we would have said this is not a real number, but now what we can do is we can break it apart into the square root of 16 times the square root of -1. We know that the square root of 16 is 4, and we now know that the square root of -1 is I, so the square root of -16 is equal to 4I. Let's look at one that we have to break down a little further. So let's look at the square root of -20. So again, we can start by breaking this apart into the square root of 20 times the square root of -1. But 20 isn't a perfect square, so we want to break that apart into, again, the largest perfect square times another number. So we'll break this apart into the square root of 4 times the square root of 5. Again, we want to use 4 and 5 because 4 is a perfect square. And then we still have this square root of -1. Now, just like we were doing before when we were simplifying, we'll take the square root of all the perfect squares. So the square root of 4 is 2. The square root of -1 is I. And then this 5 that's not a perfect square will stay under the radical, so we have 2I square roots of 5. Now, sometimes all we can do is separate the negative. So let's say we have the square root of -17. The only thing we can do is break this apart into -1 times the square root of 17. And we can only take the square root of the -1 as I, and then the 17 will have to stay under the radical. So even though the 17 isn't a perfect square, it doesn't mean it can't be simplified. We still need to make sure we take out the negative by using I. And then finally, just a reminder that we can have a negative under a cube root like this. So in this case, the cube root of -64 is simply -4. There is no I in this one. So this is only for square roots and other even roots, like if we had a 4th root or a 6th root. Now that we're working with I, this is going to require us to also work with complex numbers. So the form that we write a complex number is what's called A plus BI form. So the A represents the real number part, and the plus BI represents the imaginary number part. So anytime you have a number that has a real number part and an imaginary number part, the real number part has to go first and the imaginary number part has to go second. So for example, if we had the square root of 16 plus the square root of -36 and we wanted to simplify this, the square root of 16 is 4. And then we have plus, and then the square root of -36 would be 6I. So this is how we would write this number. We cannot combine those two. This is the real number part, the 4, and the 6i is the imaginary number part, and it always has to go second. So now let's look at some operations with complex numbers. So just like expressions that have x and y in them, we can add, subtract, multiply, and so on with complex numbers. So here, the first thing I want to point out is that we have two numbers here. This is the first number, and this is the second number. The only reason the parentheses are there are just to separate the two numbers from one another. And it's important to note that this is an addition problem. We are not doing any multiplication here. Again, the parentheses just represent that we're separating the two numbers from each other. So what we're going to do is we're going to add the real number parts together. So -6 plus -9 is -15. And then we'll go back and we'll add the imaginary number parts together. So -8i plus -3i is -11i. So we're just getting a total, which means the exponent on that I does not change. We want to write it in a plus bi form, so -15 minus 11i is our final answer. So the next problem is similar. The only difference is now we have subtraction. So the thing you have to watch with subtraction is you have to make sure to distribute that subtraction to everything inside the parentheses. So we're subtracting 2 and we're subtracting a -3i, which means we're really adding a 3i. The first part, the -5 plus 4i, stays the same. And now we're just going to combine like terms. So we'll start by combining the -5 and the -2, which gives us -7. And then we'll go back and we'll combine the 4i and the 3i to give us +7i. So our answer is -7 plus 7i. Next, let's look at a multiplication problem where we have to distribute. So we're going to start by distributing the -2i to the 7, so we're going to multiply. That gives us -14i. And then we'll multiply -2i times +3i, which gives us -6i squared. Now remember, we talked at the very beginning of the video that I squared is equal to -1. So anytime we see an I squared, we can replace it with a -1. So everything else will stay the same, but we will replace that I squared with -1. So now we can take care of this multiplication. That gives us -14i plus 6. The only problem here is that this is not in a plus bi form. We need the real number part to come first and the imaginary number part to come second. So we must rewrite this as 6 minus 14i. And this would be our final answer in a plus bi form. The last thing we're going to talk about are higher powers of I and how to figure those out. So let's say, for example, we wanted to figure out what I to the third would be. Well, we can think about this as I squared times I. That would still give us I to the third. We know that I squared is -1, so we would be doing -1 times I, which is just -I. So I cubed is equal to -I. Now let's look at I to the fourth power. So again, we can use I squared here. We can think about this as I squared times I squared. And we can replace both of those I squareds with a -1. So -1 times -1 is +1. So I to the fourth is equal to +1. And we could just keep going from here. So let's say we wanted I to the fifth. Well, we already know I to the fourth to be, we just figured it out. And we can break this apart into I to the fourth times I. We figured out that I to the fourth was 1. So 1 times I is just I. So I to the 5th would be equal to I. So we can use smaller powers of I to figure out larger powers of I.